To this tutorial, we'll continue our case filling tank. The second video will treat the meshing. So be sure that you are in space clay. Just in space clay, geometry space clay. So there are our space clay. First, we will upload our geometry. We'll just upload our geometry exported by FreeCAD. Go to Assembly, File, and add our tank. So this is our geometry. Just we will convert it to solid for going to meshing. Go here, merge the face. So we see the cylinder have imported by mini portion. We can just go to repair and merge the face for facilitating the inscription of the boundary condition of walls here. So just merge the face. Continue for this. So there are our geometry. We merge all the portion face. So let's go to the meshing. Just we open our mesh. So there is our geometry imported in the mesh. So we chose a method for meshing. Just for simplification, we chose just a Cartesian meshing. So select our geometry. For the chosen, let's set the boundary condition. So for here, you given each face and name it for the boundary condition. Here we have elite. And for the cylinder and this part, the other part, walls, and this face is the top. Okay, this face is the top or Z axis. This is the top. Top for the rest is the wall, just in the same just in the same way we can assign our walls. So there are our boundary condition. This is the top, the inlet, and the walls. Just let's start our mission. We will select a Cartesian type for simplification. Okay, there we select our method, and which shows a machine with 0.3 meter. I changed the geometry of the walls. We can change the geometry if just following the first video and change the geometry as you like. Just for simplification, I changed the geometry to be in the meter. If we watch the first video, we have the geometry is stated was stated in millimeter. In this case, I will set all in the meter. So I will change. I will choose 0.3 meter for the mission, a Cartesian mission. That generates. I will check the quality of the mesh using OpenFOAM. Can just process our mesh. Look, it's very good. So this is our mesh. Okay, just we export the mesh. Export the mesh. Can export before export? Be sure that the mesh will it's exported in ASCII file. So we give it a name, for example, mesh tank. So there is our machine exported. The part of the fluent is ended. Just let's move to the next step for importing the machine importing the machine exported in OpenFOAM. Okay. So we'll open our case. We'll move the file. Move the file here in the mesh in the file of filling tank. Just take a quick look on the on the on the folders. Of each folder we have the 0 folder that contain the instance 0 for each parameter. We have the alpha watcher origin. So this is our field, and we have a lit fixed value. We will show the fixed value in the U file. So this is our phase of watch, and we have the K also for. And you show that just setting the proper geometry of the name just should be hidden for the exported and the fluent of the inlet. So the value in channel field 0.05 in the inlet, and the walls we have a cars word function, and each file I will share with you the file in the third video. And also we have a constant just polymesh, because we have the polymesh here. We will show how to call, and the block mesh. Block mesh doesn't need it because we have use fluent, so we have already have the meshing. So and also the exported mesh, you should move it here. So so we tap Fluent 3D Mesh to Foam, and we just move for the file, fill tank 1T. Okay, you have Fluent 3D Mesh, just choosing mesh tank, the same name, and run it. So we have also, we can check our mesh. So it's okay, and we can we can just publish our meshing to view in ParaView. Okay, touch S.Foam, open our ParaView. So there is our ParaView. Just low, we can move, and we have the inlet patch. So this is the inlet patch, the top patch, and the walls. And we can also show the surface edges. So this is our geometry setting. See you in the next video.